Okay, in this presentation we're going to look at an annual average rainfall comparison for two countries. Now this exercise is quick enough. An analysis was carried out to analyse and investigate the annual average rainfall of two countries. So here is the rainfall data for Iran and Belgium from 1974 to 1991, and some information for Iran is missing. Okay, so we have some years there and the annual rainfall, average rainfall in both countries, but some Iranian data is missing in the 80s. Anyway, so we're going to set it up like that. We'll just use the recorded data sets as is for this analysis. So we have about 10 observations for Iran and I think 18 observations for Belgium. And we're just going to do a quick comparison of the two. So the exercises feature hypothesis testing and confidence intervals. Perform a suitable hypothesis test to determine whether the rainfall in both countries has equal variance or not at a 5% significance level. B. Test whether the mean rainfall in both countries is equal or not at a 5% significance level. Calculate the 95% confidence interval for the difference in means and comment on the results in exercises C and D. So, equal variance test. We're going to perform an equal variance test to determine if the variances of rainfall between the two countries is equal or not. Okay, so H0 variances are the same for both countries, and H1 the variances are different for both countries. So the command here is var.test. Okay, Iran and Belgium. So just name the two data sets or the two samples. Okay. So this is the result, F-test to compare two variances, and the data is Iran and Belgium. The p-value is 0.0438, so we are going to reject the null hypothesis. Interestingly, the alternative hypothesis is specified in terms of the ratio of the variances, okay? So the 95% confidence interval specifies the variance ratio. So this is the variance of one country divided by the variance of the other country, and the test actually works on the basis of that ratio. And so the alternative hypothesis of difference is expressed as the true ratio is not equal to 1. Okay. The ratio of the variances, interestingly, is 0.258. Anyway, we reject the null hypothesis and we conclude that the variances are not equal. So now we're going to perform a hypothesis test with unequal variance specified. So using a t-test with unequal variance to test if the mean value is the same. So it's t-test, Iran and Belgium, once again the two data sets, the two samples, okay? But we're also going to specify this additional argument, var.equal equals false. So this will tell R to use a Welch two-sample t-test, which does not rely on the assumption of equal variance. Okay, so there's a different one if you do. If you have just t-test Iran and Belgium, it actually creates a different test. But we'll sort of not worry about that for now. Okay. Anyway, so the p-value there is very small, 3.407 e to the minus 0.5, okay? Incredibly small number, okay? So it's much less than 0.05. The alternative hypothesis is the true value mean is not equal to 0. And the confidence interval for the difference in means is between minus 42.79 and minus 17.85, okay? So the mean of X is Iran is 126 and the mean of Belgium, which is Y, is 156.722. So anyway, since the p-value is less than 0.05, we reject the null hypothesis and conclude that the mean rainfall in Belgium and Iran is different with 95% confidence. So just to highlight the 95% confidence interval, because it is the answer to exercise C, just notice it in there right in the middle, okay, minus 42.8 to minus 17.8, allowing for rounding. So there we have it there. The 95% confidence interval for the difference it means is provided here in this output. Okay, that's just a sort of zeroing in on where it is. But there we have it there in the test, and this is what I specifically want you to find. So wrap it up. The confidence interval minus 42.8 and 17.8 minus 17.8 does not contain 0. So this indicates that the mean rainfall is significantly different between the two countries in this time period. The result aligns with the conclusion of the t-test in exercise B, affirming that Iran and Belgium has significantly different data with regard to rainfall. Significantly different average rainfall, I should say. Right, okay, we'll leave it there.